In a previous video, we have seen that we can create an empty shell for a class. Considering the class rectangle, for example, we use the shell to add attributes for an instance by using the name of the object dot the name of an attribute. Unfortunately, by doing so, we cannot enforce consistency. We were able to add the length L for one of the rectangle, and then we use the height h for another rectangle. Therefore, when we created a function using all these attributes, we had an error. To solve this issue, we need to override the initializer of the class. That is, we need to implement the method init. The init method is called immediately after an instance of the class is created by __new __ method. The new method is the constructor. In many texts, though, init is incorrectly called the constructor of the class. Even though it is incorrect, for consistency with many textbooks, we will use the term constructor to refer to the method init. By convention, init, which is in fact __init __, is the first method defined for the class. It is the first piece of code executed in a newly created instance of the class. The class rectangle is a definition of the type of object. R is an instance of a rectangle. X and Y are instance variables, and init is a method. The next things we want to do now is to be able to create an object using the init method. The init method will ensure that every instances of the rectangle will have the attribute x, y, w, and l. You may have noticed that we use the term method instead of function. A method is a kind of a function, but in addition, it is part of a class. It is defined within the class and therefore it is indented within the class declaration. A method using the same keyword as a function, def. In addition, when declaring a method, there is always at least one parameter. By convention, the name of the parameter is self. It is a convention and you could use any other name, but it is frowned upon by the Python community. Once the header of the method is done, we want to define the four attributes of the class rectangle. To define an attribute within the method, we first call self dot, then the name of the attribute. In our case, we will create four attributes and assign them a value. The first one is self.x and we assign it a value of 0. We do the same for the attribute y, w, and l. One important thing here is that I do not need to change the function area rectangle. As you can see from the code, the method init is indented, whereas the function area rectangle is not. It means that area rectangle is not part of the class rectangle. It is not a method from the class. Now, let's see if your code is working. R is a rectangle at position 0, 0 with an area of 1. When the program is executed, we have the expected result. Like in our previous video, let's define another rectangle P. The initialization process is the same as for R, and then we can change the value for the attribute width and length using p.w and p.l. When the program is executed again, we can see that the position of the rectangle is 0, 0 like R, but this time the area is 6. We have been able to modify the state of our object P. This is better than our first attempt at rectangle. But we can do even better. We can add parameters to the init method. The idea here is to be able to initialize all the attributes of the rectangle as soon as we call the constructor. We want to avoid the two-step process we use for the rectangle P. Here is an example why we want to avoid the two-step process. Let's say that in our previous implementation, we made a small mistake. Instead of changing the length via the attribute L, we changed the length using another name for the attribute. We used H. Let's remove the statement on line 17. So the only change of the to the state of the rectangle P is via P.H. When executing the code, we notice that the area did not change. However, compared to what happened the last time we used the wrong attribute's name, the program did not crash. That's progress. In fact, the rectangle P has now 5 attributes: X, Y, W, L, and H. I hope you agree that it would be much better if I could create a new object directly with a given set of values for its attribute X, Y, W, and L. To do that, we must refactor the method init and add 4 parameters. Let's call them cohort X, cohort Y, width and length. Then we can assign this parameter to their corresponding attribute like so. Now that we have refactored my init method, we need to pass the 4 values to the rectangle constructor. For example, we can use the value 0, 0, 1, 1 for the rectangle R, and the value 1, 1, 2, and 3 for the rectangle P. Let's execute the program to check the output. As expected, the 2 rectangles are initialized properly, with their own values. We do not need a 2-step process to create a rectangle. Our implementation is becoming more robust. We have seen that we can provide default value for a parameter in a function. We can do the same for method. Keep in mind that the same convention and restriction apply. For example, we can define that a default rectangle will be at position 0, 0 with a width of 1 and a length of 1. When creating a default rectangle, we can omit the parameter in the constructor call as shown on line 12. What else could we do to improve our implementation? All rectangles have an area. This is a property of a rectangle. It will be convenient to attach the area rectangle function to an instance of the rectangle. In order to achieve this, we can create another method within the class definition. Let's call this method area. The method has only the parameter self, which represents the object itself on which area is going to be called. I agree that what I've just said is a little bit obscure. I promise it will become easier, clearer later. To compute the area of my rectangle, I just need to return the product of its 2 attributes, self.w and self.l. Compare the definition of the method area with the function area rectangle, and you will agree that they are pretty similar. The only difference is the name of the parameter. In fact, we could have used rect for the name of the parameter in our method. That would work perfectly fine. However, we would be breaking an important Python convention, and it would make our code a little bit harder to read for another developer. Let's update our output to see if we obtain the same result when computing the area of R using the 2 approaches. Thankfully, the output is as expected. Both computations return a value of 1 for the area of the rectangle R. Hang on a minute here. The method area has 1 parameter. However, when calling it, we don't pass a parameter. What's going on? In fact, in Python, there are 2 ways of calling that method area. The other way to call the method is by giving the name of the class where the method is defined, in our case, rectangle. Dot, the name of the method itself, in our case, area. And in the parameter, the object onto which we should apply the method, in our case, R. You can see that in this case, when calling the method area, we must provide one parameter, the parameter for the rectangle R. When executing the method with the two different invocations, we have exactly the same output of 1. The call r.area is a more convenient way to call the method, and it is also the preferred way to call it. So remember, when defining a method, you must always have at least the parameter self. This is a common source of error, especially among programmers that have used a language like Java, where no such parameter is needed. To be sure that the code is working as expected, we should print the area of the rectangle P using the method area. As expected, the method returned the value 6. We have made a lot of progress, and our code is becoming more and more robust and convenient to use. We can initialize a rectangle by passing parameters in the constructor, and we know how to define new behaviors. As an exercise, you could try to implement a method to return the parameter of a rectangle, or another method to return a list containing the coordinates of the 4 corners of a rectangle, given the position of the top left corner, its width, and its length. Despite great progress, we are not done yet. Users of our modules, and in particular users of the class rectangle, could do bad things. Remember, be wary of the almighty user. For example, someone could initialize a rectangle with a negative width. We need to protect the integrity of our objects. We need data encapsulation. This is the subject of our next video.